Hi, today I'm going to be presenting 2015 AMC 10A problem number 23. The zeros of the function f of x minus x squared minus ax plus 2a are integers. What is the sum of all possible values of a? So the way we're going to solve this problem is, first of all, zeros is basically just roots. So let's use a quadratic formula to find the roots. A plus minus square root of a squared minus 2a times 4 times 1 over 2 is equal to a plus minus square root of a squared minus 8a over 2, and that's equal to the roots, both of the roots. Now we can simplify this further. A plus minus square root of a squared minus 8a over 2 is equal to a plus minus square root of a times a minus 8 over 2, which we can further simplify to a plus minus square root of a minus 4 squared minus 16 over 2. We can do this because a times a minus 8 can also be written as a minus 4 plus 4 times a minus 4 minus 4, which is the difference of squares, so we can factorize. Now, we also have to make sure a and square root of a minus 4 squared minus 16 are both odd or even, and also square root of a minus 4 squared minus 16 is an integer because they have to be integers. But we'll check that later. So now, we can write a minus 4 squared minus 16 as I squared, let's just say, because it has to be a perfect square, so let's say it's I squared. We can represent this diagram, I squared plus 16 is a minus 4 squared. Now we can actually, in fact, plug in another j squared in between. I squared plus 7 is equal to j squared, and j squared plus 9 is a minus 4 squared. We can do this because, first of all, when you subtract two squares, if there are two consecutive squares, their difference is always odd. And if their difference is always odd, these I squared and a minus 4 squared can't be consecutive squares. But they can be two consecutive squares, 7 and 9. If they differ by 7 and 9, 7 is an odd number and 9 is also an odd number, and they're consecutive odd numbers. Consecutive squares always differ by consecutive odd numbers. For example, 0 and 1 differ by 1, 1 and 4 differ by 3, 4 and 9 differ by 5, and they're consecutive odd numbers. So 7 and 9 are consecutive odd numbers, so that means I squared and j squared are consecutive squares, and j squared and a minus 4 squared are also consecutive squares. Now we can actually find a minus 4 squared. We know I squared is 9, j squared is 16, and a minus 4 squared is 25. Because there's only a few possible values of I, j, and a minus 4 that make this true. I squared is 9, j squared is 16, and a minus 4 squared is 25. We can verify. 16 minus 9 is 7, j squared minus I squared. 25 minus 16 is 9. So this holds true. Now if a minus 4 squared is equal to 25, then a minus 4 is equal to plus minus 5. So a minus 4 could be 5, or it could be negative 5. That means a is equal to 9, or a is equal to negative 1. These are just two possible values of a. There's actually more possible values of a, because notice that these have to be consecutive odd numbers. They don't have to be only a series of odd numbers with length 2, like 7 and 9. If you put them in like a list or something, then they have a length of 2. We never have to restrict ourselves to only length 2. We can also do length 3, length 4, any type of lengths. We can't do length 3 with this because 9 and 7 have an average of 8. And 8 times 2 is 16. Or in other words, 8 times the length of this list is 16. So that means the length of this list has to be divisible by 16, only for it to be valid. Otherwise, we wouldn't really be able to create that chain. But in this case, 2 is divisible by 16, so that's why this works. But 3 is not divisible by 16. The next number that is divisible by 16 is 4. So we can have a series of consecutive odd numbers that sum to 16, and they're of length 4. Because their average has to be a whole number. If they're odd numbers, their average is a whole number. And 16 is divisible by 4, so their average will be a whole number. And those four numbers are 1, 3, 5, and 7. You add them, they'll sum to 16. We can also define them with variables, the difference with variables, w, x, y, and z. So now we have another possible we have another possible equation. W squared plus 1 is x squared plus 3 is y squared plus 5 is z squared, and z squared plus 7 is a minus 4 squared. We can again find a minus 4 squared. W squared has to be equal to 0, x squared has to be equal to 1, y squared will be equal to 4, z squared is 9, and a minus 4 squared is 16. We can verify 1 minus 0 is 1, 4 minus 1 is 3, 9 minus 4 is 5, and 16 minus 9 is 7. So now a minus 4 squared is 16. And again, we can do a minus 4, basically plus minus 4. A minus 4 is equal to plus minus 4. So a minus 4 could be 4 or could be negative 4. When we solve, we get a is equal to 8 and a is equal to 0. Now, you might think there's more possible values of a, but this is it actually. So 4 is divisible by 16. The next number actually divisible by 16 is 8. And we can't have a series of odd numbers with length 8 because then that would extend to the negatives. And squares could have negative differences, but if they're consecutive squares, like x squared is bigger than w squared, then they can't really have negative differences because we can't have negative squares. So this is actually all the possible values of a. And now we could check if this holds true, if this is odd and even. Remember I mentioned that earlier. So if both of these are odd, a and square root of a minus 4 squared minus 16, or just a times a minus 8 square root, we can check if they're both odd or even. With 9, we get 9 is a, so 9 is odd. And 9 times 9 minus 8, which is 9 times 1, which is 9, square root is 3. And 3 is also odd, so 9 holds true. A is equal to negative 1. A is equal to negative 1 is also odd. And negative 1 times negative 9 is 9. And 9 square root is 3, so again, it's true. A is negative 1 and square root of a times a minus 8 is 3. And it's both odd, so they can be integers. So 9 and 1 hold true. Let's check 8 and 0. If a is 8, then that means square root of a times a minus 8 has to be even. 8 times 8 minus 8 is just 0, and 0 square root is just 0. And 0 is also even. So 8 is true also, and a is equal to 0. So 0 is also even, and then we have 0 times 0 minus 8, which is 0. So that's square root of 0, which is 0, and that's also even. So all of these values of a hold true. Basically, all these values of a make this quadratic have integer roots. So now we just have to find the sum. 8 plus 0 plus 9 plus negative 1 is 16. So the answer is C.